want to take a minute and read the problem. I'm going to let you do that yourself. As you go through and read the problem, you notice that the diameter is 197 feet. It rotates one complete revolution every 15 minutes. That just gave you your radius and your period. We are 12 feet above the ground. Now it asks you to make a table. I'm not sure we need to make a table. We've done this before, so we're gonna cheat a little bit, and we're gonna identify a high point and a low point. So what we need to do first, we need to go through and we need to find the amplitude, the period, the B, the H, and the K. We're going to suggest that at some point you go ahead and sort of sketch this if you want, give you an idea what the high and the low is. So for the amplitude, we're looking at the maximum y value minus the minimum y value divided by 2. Maybe we ought to also go ahead and look at the Ferris wheel. So let's go ahead and do that. Here's your Ferris wheel. It is 12 feet above ground. So this point right here becomes 0, 12. If we go all the way to the top, that ordered pair now is 197 plus 12 at 7.5 minutes. So 209. Diameter we said was 197. Radius therefore is half that. 98.5. We'll see if that comes into play at all. All right, so back over to the amplitude, we've got 209 minus 12 divided by 2. Oh, look at that. It does come into play. We got 197 divided by 2 is 98.5 feet. The period we know is 15 minutes. The B value is 2 pi divided by 15. I would just leave it at that. We don't even need to go any further. We're going to skip down to K. K is the maximum Y plus the minimum Y divided by 2, or 209 plus 12 divided by 2, or 110.5 feet. So if we go back to plotting this thing, we know that our period here was 15, half that's 7.5. So if I take this up to, 200, 100, and I start plotting points, the high point is at 7.5 seconds is going to be all the way up here at 209, and the low point is going to be at 12. So what happened here is we've got this half of the period. And when we started the graph, this thing started like this, and there's my cosine function. That's a thing of beauty, because now we just need a high point or a low point or a low point. All right, so my starting point, I would say, is 7.5, the high point of the cosine function. So y equals 98.5 cosine. B is 2 pi divided by 15, x minus 7.5 plus 110.5. If I were to do a cosine from 0, we could also use 0 before time started, but that's going to be y equals negative 98.5 cosine 2 pi over 15x minus 0 plus 110.5. Question now is, do we need an equilibrium point? If we wanted to do this as a sine function, my equilibrium point is going to be 98.5, so that's going to be somewhere in here. If I had graphed that correctly, those points right there theoretically are my equilibrium points. That should be halfway between 0 and 7.5. That would be these points right there. Half of 7.5 is 3.75. And this would be also comma 98.5. So that's those 2 points. So my sine function, if you will, is now, or as a sine, h equals 3.75, y equals 3.75 sine 2 pi over 15, x minus 3.75 plus 110.5. You could also do a negative if you wanted to use this point right there, but that's up to you.